we are going to use, or I'm going to use in converting SC to DC, which is our project and a product that is going to be able to charge most of the small gadget components, electric components like radio, robots, Nokia chargers, and other gadgets which uses a voltage between 3 voltage output to 5 voltage output. So we have a transformer, of which this transformer is having the secondary part of it, which we are going to use as our voltage input. These red wires, we shall connect them. We are going to be connecting them to the input, which will be connected to the socket, or to the 4-pin plugs, which will receive the 240V to convert it to a relatively large amount of DC output. But to achieve our goal, we shall be connecting the diodes. Our diodes are these ones. They are going to be 4 in number, such that it is rectified. Our major principle in this physics is to rectify, which is rectification principle, which states that the converting of AC to DC such that it is properly regulated for usage. So the capacitors will be connected in series such that it continues regulating the 12V that will pass through it, and we shall, instead of using the sync diode, we shall use the all voltage, the all board. Its purpose is to continue lowering or leveling the 12V or 15V that would have passed through these capacitors, and to regulate it through. So this capacitor will try to lower the 12V. The transistor here, the diode here will prevent the forward backup bias, and this will act as our regulator or the potential divider. The purpose of it is to continue regulating the voltage that would have passed through. In other words, in local technology, we could use the Zener diode, but this is an improved one. It will continue regulating the pulses that would have been passed through to smoothen it, to prevent the humming sound, as we shall be seeing the graph diagram of the V high in our report. So the relatively produced V is going to pass through another capacitor, which would have been ready for usage. However, we shall also connect a resistor. This resistor is responsible for being connected to our light emitting diode, which is also known as the lead. The lead, which shows whether the power is on during usage or off. So it controls the power that will show that will give light in the light emitting bulb. So itself can also be called light emitting diode.